Good evening, everyone. As promised during class, I wanted to work through the bonus problem from the exam that we took yesterday, or on Tuesday, the 1st of February. I know that this isn't going to necessarily get a lot of attention, that most of you aren't super interested, but at the same time, I did want to work through it once, as much for providing the people that worked on it a solution and sort of a rationale behind it and what I was doing when I was writing it, as well as because I think it's kind of interesting to see so many different concepts and ideas and pieces of this last unit come together in a single problem. That was my goal when I kind of fiddled around playing with it, was trying to come up with something that would introduce or tie together like 4 or 5 different pieces as we went through. So that's what we got here, is this complicated, convoluted bonus problem that hinges on, like I said, 5 things from this unit. So to kick things off, as I read this the first time, I noticed that it says in the first line, the average value of p of x equaling 2x plus 5g of x, for some function g that we don't have defined in any way, on the interval from 4 to 6 is 12. So basically, I want to start there. The average value of p of x on 4 to 6. So even before I read the second half of this bonus question, I want to start by just translating that into math, because odds are we're going to need that information. We'll see how far we can go with it. So the average value on 4 to 6, so that's going to be 1 over 6 minus 4 times the integral from 4 to 6 of p of x dx. And then they did give us p of x, so I'm going to go ahead and take that one step further. This would be 1/2 the integral from 4 to 6 of 2x plus 5. That's a terrible 5. 5g of x dx. So basically that's what they gave us first. And then second, it says that's equal to 12. Now, adding that second move right off the bat, again, by the way, I'm only looking at the first line of this bonus question so far, so I might be barking down the wrong tree, but I wrote the question, I know I'm not. Is basically in here, we can find basically everything about this integral expression on the left side. The only thing is we don't know what g of x is. So my thought is, let's see where we go. Maybe we can solve for g of x. So I'm going to actually indulge that idea here and just proceed forward. Like, let's just move and see where we get. So from here, what am I going to do? I'm going to first multiply both sides by 2. So in a sense, like, I should probably clarify that thing right there. I'll make that an imply sign. I'm going to multiply both sides of this equation by 2. So that's going to just give me the integral from 4 to 6 of 2x plus 5g of x. I'm also going to use the integral properties there. I'll just do them at the same step. So the integral from 4 to 6 of 4 to 6 of 2x dx plus 5 times the integral from 4 to 6 of g of x dx. And that whole thing is now equal to 24. So from here, I'm going to keep working through these pieces. The first move that I'm going to go through is right there. So this is the integral of 2x. That's going to be x squared evaluated from 4 to 6. That's going to be 36 minus 16, which is 20. So that means this equation, the first expression will be 20. Then from there, we're going to add 5 times the integral from 4 to 6 of g of x, something we don't know. And then, of course, this entire thing is equal to 24. So now from here, moving a few pieces around, you can probably anticipate where this part's going. I'm going to subtract 20 from both sides. When I do, obviously that's going to zero out. We're going to get 5 times the integral equals 4. And then last but not least, I can solve for the integral. So again, moving this down just a little bit so we have it in clean space. The integral from 4 to 6 of g of x dx is equal to 4/5. And I will point out that this piece was the first spot where you could earn points. So if you got to that integral equaling 4/5, which a number of you did, you would earn 3 points out of 0. It's a bonus question. It's extra credit. So there's sort of our first piece of information. In fact, I'm going to take this with us to the next page. But we've tackled the first statement of this bonus question. Our result was this sort of integral relationship. So the question that comes up next is, well, what am I going to do with that relationship? Like, what is there left to do? And the answer is, just this massive, monstrous function h prime of x. So there's some derivative h prime. And then there's some function values that we're playing with. And actually, that's sort of an interesting place to take a pause for a moment. So before I dig in too far, we're given h prime. And yes, it's a whole thing, but we're given h prime. We're also told h of 3 equals negative 14. And we're asked to find h of 1. Those 3 pieces together suggest that we're going to use the alternate fundamental theorem of calculus. We're going to basically set up the fundamental theorem and then solve for something. So that's actually a huge help. That does a lot for us, actually. Like, it tells us where we're going. So that's going to be my next move. I'll set up the fundamental theorem of calculus and then sort of move things around. So first of all, our values are 1 and 3. I'll admit that's a little disappointing at first. I was hoping for 4s and 6s, but we'll see where this goes. So this will be the integral from 1 to 3 of h prime of x dx is going to be equal to, by the fundamental theorem of calculus, h of 3 minus h of 1. Now, as far as these ingredients, I can now use what h prime of x is equal to. So I'm going to do exactly that. So from 1 to 3, and this is going to be of, if I can pop the whole thing in there, this will be 14x minus 35. You know what? I'm going to factor out a GCF there. Forgive me. I feel like there's some value to doing that. I feel like it's going somewhere. Also, again, I wrote the problem, so I've got a good idea about what's helpful. So there's that. On the right side, we have h of 3, which is negative 14, and then we have h of 1, which we are trying to find. So there's what we have. So looking at the pieces here, the next question will be, well, what do we do with that? And the answer is look on the inside. I was going to say, look into your heart. No, look inside your integrand. In here, it looks like there's something inside of a function. So I'm going to go ahead and do u substitution on the left side. So u is going to be 5x minus x squared. Du is going to be 5 minus 2x times dx. Notice I'm using parentheses. That's something I think all of us, maybe more all of you than me, would benefit from using more of. But there we go. So there's our u substitution stuff. We're ready to plug that in. But in addition, I also want to make sure that I tackle those limits of integration here. Those are x values. Let's just convert them to u values. Like you never know what might happen there. So first of all, if x is equal to 3, then u is going to be 15 minus 9, which is 6. And if x is equal to 1, u is going to be 5 minus 1 is 4. Now, as soon as I say that, you might think, hey, wait a second, haven't we seen 4 and 6 before? And the answer is yes, we have. 4 and 6 match this original integral, so maybe there's some connection there. Let's find out. So up here, I'm going to start to rewrite that integral. So first, our integral was from 1 to 3. It's now going to be, use the green again, it's now going to be from 4 to 6. Huge help for us, like literally a huge help. It connects these things together. In addition, we still have this 7 and this 2x minus 5. But then g has now become g of u. And likewise, we can substitute for dx the quantity du over 5 minus 2x. But here's where, again, I'm going to be a little bit slick. I see we have a 2x minus 5. I'm going to factor out a negative 1, and therefore write it as du over negative 1 times 2x minus 5. Now that move allows us to divide out the 2x minus 5s, which is awesome. That makes this eligible for substitute, in a sense, eligible to be evaluated. We've gotten this so the integrand is now just in terms of u. And in fact, u can continue forward by moving the scalar stuff out in front. That'll be negative 7 times the integral from 4 to 6 of g of u du. And oh my gosh, do you see what just happened? Do you see what just happened? Basically, if you didn't see it, that's okay. Like, I will point it out for you. This integral, sorry, not the 7. This integral is the same thing as what we found from the first piece of information. So what we've just shown is that integral we were trying to find is equal to negative 7 times the integral from 4 to 6 of g of u du. That's going to be negative 7 times our value up there, which was, if memory serves, and also my eyes work, 4/5. So based on all this information, we've just shown that this entire integral is equal to negative 28 over 5. So recapping, this is negative 28 over 5. Now what does that mean? Well, taking this stuff down a line just to finish this up, our integral is negative 28 over 5, and that's equal to negative 14 minus h of 1. So all that's left is for us to solve for h of 1, which is thankfully something that we are pretty good at able to do. So let's do it. I'm going to add h of 1 to both sides. Again, this is my move of doing it. And then I'm going to add 28 over 5 to both sides. So once I do that, I'll do that right here. Once I do that, I'm now going to have h of 1 is equal to 28 over 5 minus 14. And now the only thing I could do is, of course, this is the right answer, by the way, but clean this up a little bit. You never know what's going to happen. So I'm going to multiply up and down by 5 over 5. It's going to give me 28 minus 70. Don't know what happened there. All over 5. And that is, by the way, negative 42 over 5. And there is the answer to our bonus problem. So just taking a quick inventory of the stuff that we did here, we used average value. We used two integral properties. We used the fundamental theorem of calculus. And then we used the alternate fundamental theorem. We used a fairly tricky, but not impossible or super advanced U substitution. And then we finally just did some basic algebra. So like I said, 5 huge concepts, 5 of the big ideas from this unit, all brought together into a single problem. And again, if you were in second or fourth period and you did this bonus question, I believe your answer was, what was it? 28 over 5 minus 2e to the third. I think that was your answer. But, it's basically just 28 over 5 minus whatever your initial condition was. So with that said, I'm going to stop right there. That hits the full bonus question. Hopefully that was interesting for you if that was something you wanted to see. If not, then why were you watching? Although maybe it's out of loyalty, in which case, thank you. I make $0.00 off your viewership, but I appreciate it nonetheless. So I'm going to stop it there. Have a great night. It's my bedtime. Bye.